11:32 a.m. on October 30, 1961, humans created a second sun, soaring 10,500 meters above an archipelago north of the Soviet Union. It was the most powerful weapon ever tested in human history. But let's first understand how we reached this point. Scientists had known since the late 19th century about the possibility of extracting energy by splitting atomic nuclei, known as nuclear fission. By adding a neutron to a stable atom like uranium, it becomes unstable and splits into two lighter elements, barium and krypton. However, there's a remarkable detail that makes this reaction incredible. When we add up the mass of the barium and krypton produced during the fission process, the combined mass is slightly less than the mass of the uranium that generated them. So, where did the lost mass go? According to Lavoisier's principle, nothing is lost, nothing is created, everything is transformed. The seemingly lost mass actually still exists in the universe but has been transformed into energy. Although the energy released by the fission of a single uranium atom is insignificant in our daily lives, when multiplied by the 2.56 billion uranium atoms in a gram, the result becomes significant. A gram of uranium can generate enough energy to power 45 houses for an entire month. Now, let's go back in history. A few months before the start of World War II, a German scientist named How to Run successfully achieved nuclear fission for the first time in history in his Berlin laboratory. This marked the official beginning of the nuclear era. However, don't let the term nuclear deceive you, as it had a rather negative reputation. Nuclear energy promised a world with an extremely efficient energy source. Countries facing or anticipating high energy demands could have their problems solved in a cheap and efficient manner. The news of the first successful nuclear fission quickly spread worldwide. Unfortunately, the joy was short-lived as Germany invaded Poland in 1939, triggering the start of World War II. The context changed, and wars directly influenced scientific research and production. What was once the promise of highly efficient energy now became the promise of powerful weapons. Germany was ahead in this race, so in 1939, a letter written by Hungarian physicist Leo Szilard and signed by none other than Albert Einstein alerted then US President Franklin Roosevelt that Germany might be able to build atomic bombs. Thus, the US government started its own nuclear program, known as the Manhattan Project. Spoiler alert, Germany didn't build the bomb. Shortly after, in 1942, the Manhattan Project was established to develop atomic bombs by the United States. Just 3 years later, in 1945, the world witnessed the first nuclear bomb in human history, a result of the Manhattan Project. The bomb was tested, and only 21 days after the first test, the city of Hiroshima in Japan was bombed. 3 days later, it was Nagasaki's turn. And just 3 days after that, Japan officially surrendered, marking the end of World War II. But the story doesn't end there. With the conclusion of World War II, humanity witnessed the dawn of a new phase of tensions, the Cold War. This period brought us dangerously close to the brink of civilization's end, as nuclear tests were conducted incessantly for the sake of demonstrating power. In 1962 alone, 178 nuclear tests were conducted, 96 by the United States and 79 by the Soviet Union. Throughout history, more than 2,000 nuclear tests have been conducted. If you think that the fictional bombs like those dropped on Hiroshima and Nagasaki were the most powerful ever made, you underestimate human capabilities. Those bombs were nuclear fission devices, as I explained earlier. However, there's a category of bombs even more insane, the thermonuclear bombs, commonly known as hydrogen bombs or H-bombs. These bombs utilize nuclear fusion. In fusion, two light atoms, like hydrogen, are combined to form a new atom with a slightly smaller mass, releasing the rest of the mass as energy. The problem with fusion is that it's not easy to achieve. It requires extremely high temperatures, like the 15 million degrees Celsius in the core of the Sun. So, where on Earth can we find temperatures of 15 million degrees Celsius? In the explosion of a thermonuclear bomb. Simplified, a thermonuclear bomb works in two stages. The first stage is a fission bomb, similar to the bombs used on Hiroshima and Nagasaki. It explodes and generates temperatures as high as 100 million degrees Celsius, more than 6 times the temperature at the core of the Sun. This extreme heat ignites the second stage, which contains hydrogen as fuel for fusion. Fusion begins to occur, and this process takes a fraction of a second. The result is a hydrogen bomb. Returning to the beginning of the video, the most powerful weapon ever tested in human history was dropped from a bomber flying at an altitude of 10,500 meters over an archipelago north of the Soviet Union. The energy released by the bomb was calculated to be 1,570 times greater than the combined energy of the bombs dropped on Hiroshima and Nagasaki. The bomber had to be painted with reflective paint to prevent excessive heating due to the explosion. Even so, the crew was given only a 50% chance of survival during the test. People 270 kilometers away reported feeling the heat on their skin, and windows were shattered over a distance of more than 900 kilometers. That's roughly the distance between Sao Paulo and Brasilia. Although the bomb exploded at an altitude of about 4 kilometers, the seismic impact could be measured after circling the Earth 3 times, and the explosion's cloud reached a monstrous height of 64 kilometers, 7 times the height of Mount Everest, extending beyond the stratosphere. The era of nuclear bombs is a grim reminder of what humanity is capable of doing to itself, and the effects on the human body are still felt today. Radioactive isotopes generated by nuclear explosions are present in your body at this very moment, and regardless of what you do, they will continue to be present. Depending on your age, they may even be present in your children. Fortunately, we have moved beyond that era. Not everything about nuclear technology is destruction. The energy used in these weapons can be harnessed by a responsible and conscientious civilization. Mastering nuclear fusion could be the final step toward becoming a civilization with access to clean, cheap, and efficient energy. Thank you very much, and until next time. If you enjoyed this video, don't forget to subscribe to the channel.